In the previous video, we used the numerical approach just for explanation purposes so as to better understand this whole concept of infinite limits, or why we say the limit becomes infinity as x approaches a certain number because y is increasing or decreasing without any given bound. Now let's return to our go-to way for evaluating limits, which is direct substitution. Now, if I perform substitution over here, if I plug in over here, this is just going to give me 1 over 0. Now this is very important when you have 1 over 0. Remember, we said that when you have 0 over 0, this is indeterminate. So it's also important to distinguish between 1 over 0 and 0 over 0. Now, when you plug in and you get 1 over 0 or any constant c at the top divided by a 0, provided that c is not equal to 0, because that would just give you 0 over 0, right? So you can have 2 over 0, or you can have 500,000 or 5,000 over 0, anything provided that the numerator is not equal to 0. You can have like minus 2 over 0, positive, negative, any number is fine, as long as the numerator is not 0 and the denominator is 0. So whenever you have this sort of a situation, straight away you should know that the value that x is approaching, this is a vertical asymptote. So you can say that x equals to 0 is a vertical asymptote. The 0 in the denominator is what gives us this vertical asymptote. Let's look at another example. So this says the limit as x approaches 3 of 2x divided by x minus 3. So as always, I'm just going to plug in first. So this is 2 times 3, 6 divided by 3 minus 3, that's 0. So we know that this is in the form of c over 0. Okay, so right away, I can say that x equals to 3 is going to be a vertical asymptote. Okay, the second thing that we need to do in such scenarios is that we need to find the one-sided limits to determine whether the function is approaching positive infinity or negative infinity from both sides. Sometimes it's possible that the function can approach positive infinity both from the right or left, and many of the times as you will see that the function will approach positive infinity from one direction and negative infinity from another direction. Alright, so whenever the limit of a given function equals to this form of c divided by 0, there's two important things that we need to do. The first thing is that x equals to a is a vertical asymptote, and the second thing is that we need to find the one-sided limits to determine if the function approaches positive or negative infinity from both sides. So this is important. If you keep this in mind, then all these questions will be pretty simple for you. So now back to our example. We already did the first step. We said that x equals to 3 is a vertical asymptote. Now let's find the one-sided limits. So the limit as x approaches 3 from the right-hand side is just going to be 6 divided by x minus 3. One very important thing to understand over here is that we are approaching 3 from the right-hand side. What did we say that means? When we approach a number from the right-hand side, that means it's in the slightest terms greater than that number. So this x over here that we are plugging in is not 3, but it's a number that in the slightest terms is slightly greater than 3. Now, if this one is greater than 3 and you perform x minus 3, so this denominator is going to be a very small, a very, very small positive number, which is going to be almost close to 0. The numerator is just going to be 6, but the denominator is a very small number that's almost close to 0. So a notation to write this is that you can say that it's almost close to 0. So you can write it as 0, and we know it's positive. So we can just put this plus over here at the top. So this basically means that this is a very, very small number, almost close to 0, and it's going to be positive. So now I know that 6 divided by a positive small number, which is almost close to 0, is going to be positive infinity. So this part over here is what helped us determine this sign of infinity. Now let's do the same thing as we approach 3 from the left hand side. So the limit as x approaches 3 from the left hand side is just going to be 6 divided by x minus 3. So this is equal to 6 divided by, now what is the denominator? So we are approaching 3 from the left hand side. So that means that this x over here is slightly lesser than 3. So if this x is slightly lesser than 3 over here, the denominator is going to be a very, very small number, which is going to be close to 0, but it's going to be negative. One way to visualize this is that when we say that we are approaching 3 from the left hand side, so this x over here could be 2.999999, and if you subtract 3 from this, you're going to get negative 0.00001. So we know that this number is almost close to 0. So instead of writing all this minus 0.0001, we can just write a 0, and we know that this is a negative, right? So we can write it this way. So this thing over here tells us that the number is very, very small. It's almost close to zero and it's negative. So any number divided by a very, very small negative number is going to give you minus infinity. So again, the denominator over here helps us determine this sign. So that is why this whole concept of one-sided limits is very important when after you plug in, you get a c divided by 0 form. So in this case, since the right-hand side limit approaches positive infinity and the left-hand side limit approaches negative infinity, and of course the one-sided limits are not equal, we can say that the overall limit as x approaches 3 of our function does not exist. And x equals to 3 is a vertical asymptote. Now let's look at another example. So if I plug in, this is going to give me 4 divided by 0. So this is in the form of a constant divided by 0. So straight away, I know that x equals to 2 is a vertical asymptote. Okay. Now, this is the first part. The second part is now we need to find the one-sided limit. So let's find the limit as x approaches 2 from the right-hand side. So this is just going to be 2 times 2, 4 divided by 2 minus x. Now, since we are approaching 2 from the right-hand side, that means that this x over here is going to be slightly greater than 2. So the denominator, which is 2 minus a number that's slightly greater than 2, is going to be very small, almost close to 0, but negative in this case. So this, we can write it this way. So this tells us that the number is very, very small, almost close to 0, and it's negative. So this basically gives us minus infinity. Now if we find the limit as x approaches 2 from the left hand side, so this gives us 4 divided by 2 minus x. Okay, so that is 4 divided by, now in this case, we are approaching 2 from the left hand side. So that means that this x is slightly smaller than 2, right? Almost close to 2, but slightly smaller than 2. So 2 minus a number that's slightly smaller than it is going to be a very, very small number, but it's going to be positive. So we can write it as 0 plus. So this basically tells us that the number is very, very small. It's almost close to 0 and it's positive. So that gives us positive infinity. Since the one-sided limits are not equal to each other, we can say that the overall limit as x approaches 2 of 2x divided by x minus 2 does not exist. And x equals to 2 is a vertical asymptote. Another way to think about this is that in the first video we say that whenever one of your limit equals to infinity or positive infinity, then it's safe to say that the value which x is approaching is a vertical asymptote. So because we know that our one-sided limit here is minus infinity, just from that, we could draw the conclusion as well that x equals to 2 is a vertical asymptote. Same thing over here, because the limit as x approaches 2 from the left is positive infinity, we can draw the conclusion that the value that x is approaching, which is x equals to 2, is a vertical asymptote. So that is how it works. Let's look at one more example. The limit as x approaches 5 of 2x squared minus 10 divided by 5 minus x. So if I plug in, this is going to give me 50 minus 10 divided by 0. So that is just 40 divided by 0. So this is again in the form of a constant divided by 0. So right away I can say that x equals to 5 is a vertical asymptote. Okay. Now I need to find the one-sided limits to determine if the function is approaching positive infinity or negative infinity from both the directions. So let's find the limit as x approaches 5 from the right hand side first. So that is just going to be 2 multiplied by a number that's slightly greater than 5. So I can write 5.1 or 5.05 or 5.5, or I can even just write it as 5, because look closely, the denominator is just a constant. So even if I write it as 5.1 or I write it as 5.2 or 5.5 or 5.01, it really doesn't matter. It's really not a factor that determines the sign of that infinity. What is determining the sign of this infinity is what's causing this 0. So that is the denominator. So that's where we need to be careful. The numerator is just going to be a constant, right? So I can just write it as 5 squared. If you want, you can write it as a number that's slightly greater than 5. So you can write it as 5.1 or maybe 5.2 or whatever number you feel appropriate, which is slightly greater than 5. Minus 10 divided by 5 minus x. So this again is just going to give me 40. Now I'm approaching 5 from the right hand side. So this x over here is slightly greater than 5. So 5 minus a number that's slightly greater than it is going to be a very, very small number, which is negative. So I can write it as 0 minus. So this basically tells us that the limit as x approaches 5 from the right is equal to minus infinity. Now the limit as x approaches 5 from the left is just going to be 2 multiplied by 5 squared. Again, I'm writing it as just 5 minus 10 divided by 5 minus x. So that gives me 40 divided by, now since we're approaching 5 from the left hand side, that means that this x is slightly lesser than 5. Now 5 minus a number which is slightly lesser than itself is going to be a very small number but positive. So I can write this as 0 plus. So that gives me positive infinity. So therefore, since the one-sided limits are not equal to each other, the overall limit as x approaches 5 does not exist. And x equals to 5 is a vertical asymptote. Don't forget this part, it's pretty important. There's definitely a mark or half a mark just for mentioning this part over here. So yeah, make sure you remember it. So this question asks us to evaluate the limit as x approaches 4 from the left-hand side. So it's specifically asking for a one-sided limit of x minus 2 divided by x squared minus 16. So let's try and plug in. So this is just going to be, I'm just going to plug in 4. So 4 minus 2 divided by 4 squared 16 minus 16. So that gives me 2 over 0. So I know that this is the form of a constant divided by 0. So straight away I can say that x equals to 4 is a vertical asymptote, right? Now I need to find out the one-sided limits to exactly determine the signs of infinity. Now a very important thing to keep in mind over here is that with vertical asymptotes and with infinite limits, right, such as in this case, whenever you're given a chance to factor, you should always factor because whether you factor or not could greatly affect the sign of infinity that you get. Now, in this case, we know that the denominator is a difference of two squares, right? So I can write x squared minus 16 as x squared minus 4 squared, which is the same thing as x plus 4 times x minus 4. So now let's find the limit as x approaches 4 from the left-hand side. So this is x minus 2 divided by x plus 4 times x minus 4. Now we are approaching 4 from the left hand side, so our x value is going to be slightly lesser than 4. Again, in this case, what value we plug in the numerator doesn't really matter. Whether if I plug 3.9 or I plug 3.95 or I just put in a 4 over there, it's either way just going to give me a constant, right? So I can just plug in 4 over there. So I'll just plug 4 minus 2 divided by, now comes the important part, the part which is determining the sign of infinity, the denominator. This is where I need to consider whether we are approaching from the right hand side or from the left hand side. So in this case, we're approaching 4 from the left hand side. So our number is slightly less than 4. So let's look at this first part over here. A number that's slightly less than 4 plus 4, it's just going to be a number that's slightly going to be lesser than 8. It's going to be a positive number. So I can just write it as 8. X minus 4 is, you guessed it right, what's causing us to have a 0 in the denominator, and hence what's causing us to have a vertical asymptote. So that means that this part over here is what actually determines the sign of infinity. So since we are approaching 4 from the left hand side, so it's a number that's slightly lesser than 4 minus 4 itself. So this is just going to be a very, very small number, close to 0, but negative. So this is 8 times 0 minus. So this basically gives me 2 divided by 8 times a number that is very, very, very small, almost close to 0, but negative, is just going to give me a very, very small number close to 0 and negative. So I can just write it as 0 minus. So that basically gives me minus infinity. So therefore, this one-sided limit as x approached 4 from the left-hand side of x minus 2 divided by x squared minus 16 was equal to minus infinity. And x equals to 4 is a vertical asymptote. So let's look at one more example. The limit as x approaches 5 of 5 divided by x minus 5 squared. So if I plug in, that gives me 5 divided by 5 minus 5 is 0 and 0 squared is just 0. So that gives me 5 over 0. So this is c divided by 0 form. So I can directly say that x equals to 5 is a vertical asymptote. And now I need to find the one-sided limits to determine whether infinity is positive or negative from left or right. So let's find the limit as x approaches 5 from the right hand side. So this is just going to be 5 divided by, like we said in the previous example, where we can factor, where we can open up, you should always do that. Now here we have x minus 5, the whole thing squared. So I can just write this as x minus 5 times x minus 5. This will help us better determine the sign of infinity. So now, as we are approaching 5 from the right hand side, we know that the x value is a number that is slightly, in the slightest terms, greater than 5. So this part over here is going to be a very small but positive number, right? Because a number that's slightly greater than 5 minus 5 is a very small positive number. So I'll write it as 0 plus and multiplied by this part over here, which is 5, which is a number that is slightly greater than 5 minus 5. So again, in this case, it's going to be a very, very small number, almost close to 0, which is positive. So it's just going to be 0 plus. Okay, so this gives me 5 divided by a positive number times a positive number is just going to be a positive number, and hence this limit from the right hand side is equal to positive infinity. Now let's do the limit as x approaches 5 from the left hand side. So this is going to be 5 divided by x minus 5 times x minus 5. So now as we are approaching from the left hand side, that means our number is slightly lesser than 5. So let's do this part. A number that's slightly lesser than 5 minus 5 itself is going to be a very, very small number, almost close to 0, but negative. Multiplied by the same thing over here, right? A number that's slightly smaller than 5 minus 5 is the same. A very, very small number close to 0, but negative. So in this case, we're going to have 5 divided by a very small negative number times a very small negative number is going to give me a positive number, right? Because minus times minus gives me plus. So this becomes a very small positive number. So that also gives us positive infinity. Now in this case, both the one-sided limits equal to positive infinity. So therefore we can say that the overall limit as x approaches 5 of 5 divided by x minus 5 square is equal to positive infinity, and x equals to 5 is a vertical asymptote. So let's look at a final example for this video. So the limit as x approaches 0 of 1 over x minus 1 over x cubed. So as usual, we'll just try and plug in first. So this gives us 1 over 0 minus 1 over 0 cubed, which is the same thing as 1 over 0 minus 1 over 0. So is this already in the c divided by 0, constant divided by 0 form? Not really, right? Because 1 over 0 is infinity minus infinity. And this is what we said was an indeterminate form. So this is one of the 4 indeterminate forms. So before even we bother about finding the limit or checking if there is a vertical asymptote or whether the limit is infinity or not, we need to get rid of this indeterminate form by using one of the algebraic techniques we previously learned. So it's obvious in this case the most suitable technique would be combining the two fractions into one single fraction. So let's do that. So we can write this as the limit as x approaches 0 of the LCD in this case is going to be x cubed. So that is going to give me x squared minus 1. So now if I plug in, I'm going to have 0 minus 1 divided by 0. So that's going to be minus 1 divided by 0. So this is constant divided by 0. So hence at this point I can say x equals to 0 is a vertical asymptote. Now I need to find the one-sided limits to check whether the limit is approaching positive infinity or negative infinity from both the directions. So this might seem a little tricky, but the x square minus 1 is a difference of two squares as well. You know, it's easy to oversee that 1 can also be written as 1 square, right? So we can write the x square minus 1 as x square minus 1 square. So that can be written as x plus 1 times x minus 1. So whenever we have infinite limits and we find the one-sided limits, we want to determine the sign of the infinity. It's always good to factor when possible. So now we'll find the right hand limit first. The limit as x approaches 0 from the right of x plus 1 times x minus 1 divided by x cubed. So now since we are approaching 0 from the right hand side, so that means that x is a value that is slightly greater than 0. So it's going to be a positive value slightly greater than 0. So adding a number that is just slightly greater than 0 to 1 is just going to give me a number that is slightly greater than 1. So I can just write it as 1. And for the second part over here, a number that is slightly greater than 0 minus 1 is going to give me a number that is slightly greater than minus 1. For example, 0 0.1 minus 1 is going to give you minus 0 0.9, right? So it's a number that is slightly greater than minus 1, but it is a negative number. So this is 1 times minus 1. So I can just write it as minus 1. So I'm writing it as minus 1 because what we're really bothered with is knowing the sign, whether the sign is a minus or a plus. The value that we're writing technically doesn't matter because we know that the limit is infinity. Divided by, we are approaching 0 from the right hand side, so it's a very small number close to 0, which is positive, so I'll write it as 0 plus, and we're cubing this thing. So this gives us minus 1 divided by a very small positive number multiplied by itself 3 times is going to give you a very small positive number. So this becomes 0 plus, and hence the limit from the right hand side becomes minus infinity. Now let's do the same for the left hand side. So the limit as x approaches 0 from the left hand side of x plus 1 times x minus 1 divided by x cubed. So in this case, our x value is slightly lesser than 0. So it means that it's a very small negative number. So you can think of it like minus 0.1 or minus 0.05. So, for example, a very small negative number plus 1 is going to be a number that's slightly lesser than positive 1, right? So, for example, minus 0.05 plus 1 is going to give you 0.95, which is a positive number, and it's just slightly lesser than 1. So, I'll just write it as 1 again because we are bothered with the sign. The sign is positive multiplied by the second thing over here. So you have a very small negative number, minus 1. So it's going to give you a number that is slightly lesser than minus 1. So it's going to be a negative number. That's the important thing. So again, times minus 1. Divided by, since we're approaching from the left hand side, so that means that our x value is a very small but negative value. So it's 0 minus, and we cube this thing. So that gives us minus 1 divided by cubing a negative number results into a negative number. So this just becomes 0 minus. And hence, this means that the limit as x approaches 0 from the left hand side is going to be positive infinity. Now, since the one-sided limits do not equal to each other, the overall limit as x approaches 0 of our function does not exist, and x equals to 0 is a vertical asymptote.